Well, very good morning all of you. In the last class, we have discussed that merits and demerits of Bohr's atomic model and de Broglie's wavelength, and next another one, Heisenberg's uncertainty principle and significance of Heisenberg's uncertainty principle. So today's topic is wave mechanic model of atom. What is it? Wave mechanical model of atom. So actually the classical theory which does not explain the dual behavior of subatomic particles. So classical theory does not explain the dual behavior. What are those wave and particle like nature does not explained by the classical theory. So the branch of science which deals with the both wave and particle nature of the microscopic particle, that is quantum mechanics. What is that? Quantum mechanics. So the quantum mechanics deals with the both wave and particle nature of the microscopic particles like electrons. So this was individually developed by Heisenberg and Erwin Schrodinger. Who are they? Heisenberg and Erwin Schrodinger. Now we will see the what is the equation for that. So Schrodinger's wave equation. So this describes the electron motion in three-dimensional wave. Electron motion, generally you know that electron revolves around the nucleus. Electron revolves around the nucleus means nucleus is the positive field. Yes or no? So electron revolves around the nucleus in three-dimensional way. So this describes the electron motion. So mainly it will describe the where the electron motion is present. Dimension as three-dimensional wave traveling in the electric field of positive nucleus. Traveling in the electric field of positive nucleus. So this is mainly describes that where the electron present around the positive field in three-dimensional way. So that is formula dou square psi by dou x square. What we pronounce one? Dou. What is that? Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square of E minus V psi equal to 0. So this is known as Schrodinger's wave equation. So this wave equation describes the electron motion as three-dimensional wave, traveling in the electric field, of positive nucleus. So what is that formula? Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square of E minus V psi equal to 0. So here x, y, z are the Cartesian coordinates of the electron. X axis, y axis, z axis. So they are the Cartesian coordinates of electron. Here psi is the wave function of electron. So m is the mass of the electron, h is the Planck's constant, E is the total energy, V is the potential energy. So this is the Schrodinger wave equation. So here psi is the wave function, V is the potential energy of the electron. Next, E is the total energy of the electron, and H is the Planck's constant, M is the mass of the electron. So now we will see the another form of Schrodinger's wave equation. Actually, Schrodinger wave equation dou square psi by dou x square, dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square of E minus V psi equal to 0. So using the symbol del, what is this one? Del. Instead of three partial differences, that is del square psi plus 8 pi square m h square of E minus V psi equal to 0. So here del is known as Laplacian operator. The del is known as Laplacian operator. Del square. So dou square side, dou square by dou x square plus dou square by dou y square plus dou square by dou z square. So this is a symbol is known as Laplacian operator. This is used instead of three partial differentials. Next another one, significance of psi or wave function. So what is the significance? It is a wave function gives amplitude of the electron wave. Gives amplitude of the electron wave. So this wave function is expressed in terms of x comma y comma z coordinates. X comma y comma z coordinates. The value of psi, the wave function may be positive or may be negative. Suppose if you observe that along the x-axis, if you observe the wave function, we may see that positive value, we may see the negative value. So if you observe that wave function, the value of amplitude increases, and reaches the maximum which is indicated by the peak in the curve. The value of amplitude again decreases after reaching the maximum. So psi in the above is a positive, the below is negative. Is it clear? So along the x-axis, the amplitude of the curve increases and reaches the maximum where the psi is a positive region. So again goes down and psi will become negative. Is it clear? So actually Schrodinger tried to give the probability of the wave function, probability of the electron. So that must be probability is always positive. The probability must be always positive. That's why he has taken, instead of wave function, he has taken psi square. This is called probability function. So probability function, if you take that psi into psi, that will become psi square. Yes or no? So even negative into negative will become positive. So the probability is always positive. Is it clear? So instead of taking that psi wave function, he has taken the probability function, that is a psi square. So what is a psi square? It is a probability function. It indicates the probability of finding an electron. Around the nucleus. Or where the electron density is maximum. Is it clear? So the intensity of light is directly proportional to the psi square. That is a amplitude. Next, the acceptable wave functions. So what is that? The acceptable wave functions are known as eigenwave functions. So what are those? The acceptable solutions of wave functions. So what are those? The acceptable solutions of wave functions, they are called as eigenvalues. They are called as eigenvalues. The acceptable solutions of wave functions, are called as eigenwave functions or eigenvalues. Eigenvalues are eigenwave functions. Okay, now we'll see the important features. So first one, when electron in an atom have certain values. So that is, you can say that quantization of electronic energy. So when electron in an atom having certain values, that is said to be quantization of energy. So the quantization of electronic energy only results or leads to the wavelength properties of electrons. So the quantization of electronic energy is directly results the wavelength properties of electrons. And next another one, wave function contains all information about the electron in an atom. Wave function contains all information about the atom, all information about the electron in an atom. This can be extracted by using the quantum mechanics. This can extracted by using the quantum mechanics. So it has no physical meaning. So it has been sign. Wave function does not have any physical meaning. Next, only probability of electron we may find, but not accurately. Only the probability we may find, but not accurate the path of the electron around the nucleus. So finally, what we can say? The probability of finding an electron. What is that? The probability of finding an electron around the nucleus. Where the probability of finding an electron around the nucleus is maximum, nearly 90 to 95%. That is called atomic orbital. What we call it? Atomic orbital. So the probability, where the probability of finding an electron is maximum around the nucleus in three-dimensional way. The maximum probability around 90 to 95%. The probability around 90 to 95%. That is called atomic orbital. So the three-dimensional space around the nucleus. The three-dimensional space around the nucleus where the probability of finding an electron is maximum. Where the probability of finding an electron is maximum around 90 to 95%. That is known as atomic orbital. That is known as atomic orbital. So these are the important features. Okay.